The last video, we learned about the factory design pattern using the example of logistic company, which chooses truck, ship, or airplane as a delivery method to deliver goods. Today, we will level up and talk about abstract factory pattern. If factory about creating one object, abstract factory is about creating families of related objects that always match each other. Let's stick to our same logistic example. So earlier we said your logistic company decide what transport to use, right? Truck, ship, airplane. Now imagine your business has expanded. You don't just need a transport method. You need entire delivery ecosystem depending on the region. For example, road logistic family, right? So truck, road packaging standard, and road invoice format. Sea logistic family, right? Ship, waterproof packaging, international seaway invoice. And the third one, air logistic family, airplane, air safe packaging, air cargo invoice, right? So each family contain multiple related products that must stay consistent and together. You can't give the customer airplane plus waterproof sea packaging or ship plus air cargo invoice packaging. That would be mess. So instead of manually selecting each product, you simply say, give me the air logistic kit or give me a sea logistic kit. And the abstract factory returns a matching set every time. That's the whole idea of creating whole family of objects that fit together. All right. So we are still in the same solution where we previously implemented the factory design pattern. Earlier, I explained how we create transport object using the iTransport interface. Now we are taking this to the next level by introducing the abstract factory pattern on top of that. To keep things quick, I have already prepared some of the codes along with the iTransport interface. We are now introducing two more interface, iPackaging for creating right type of packaging, and invoice for generating invoice format. So as you can see, I have two interface, iInvoice, iPackaging. So these three together form the delivery ecosystem for each mode of transport. Now we introduce our abstract factory, which define a set of factories, transport factory, packaging factory, and invoice factory. So I have created one more abstract factory interface, which is returning mode of transport, mode of packaging, and mode of invoice. So each delivery mode, right, road or ship, gets its own concrete factory that implement this set. So we have road delivery factory and ship delivery factory. So as you can see, this is road delivery factory, which is implementing this abstract factory. So for transport, since it's a road logistics, so again I'm using truck, and for packaging there is a road packaging, and for invoice there is a road invoice. Same for this sea logistic factory, you can see. So transport mode is again ship. So packaging we are returning sea packaging, and for invoice we are returning invoice. But parent factory is same for all, right? Invoice, packaging, and transport. Based on delivery ecosystem, it returning respective mode of transport, mode of packaging, and mode of invoice. Okay, so we have abstract factory interface. We have respective logistic factory. For road there is logistic factory, and for sea there is a logistic factory, right? So this class I already defined like ship, sea packaging, because I have used these interfaces, right? iInvoice, iPackaging. So I have created a folder for road family, right? So there is a truck implementation which is implementing iTransport interface, right? And for road packaging, I've implemented iPackaging interface. And for road invoice, there is iInvoice interface I have implemented in road invoice class. And same we have sea family. So sea invoice, sea packaging, and ship class, which is implementing respective feature interfaces. So this is factories, right? For iInvoice there is a factory, iPackaging there is a factory, for iTransport there is a factory, and we have abstract factory, which is returning all these three combined factory at a time. So for each delivery mode, I require transport, I require packaging, I require invoice even. So this is abstract factory itself, which will return respective toolkit based on mode of transport, maybe by ship, maybe by road, or maybe by airplane, right? Okay, let's collapse this. Next, I created a logistic manager class. This class uses the abstract factory dynamically. So as you can see, I'm passing abstract factory interface dynamically based on which delivery toolkit we want, road or ship, right? So I'm calling this method process shipment, which again calling packaging, generating invoice, and delivering it, right? So let's run this. So in program class, I first pass road delivery factory to the manager. When we run it, you will see it call all road specific subfactories. So let's run this. Okay, I'm simply pressing F5. So as you can see, it is calling all method related to road, right? Packaging goods with road packaging, generating road, transport invoice, and delivering goods by truck, right? Now we can switch for ship delivery factory as well, right? So let me copy this line again. Let's comment this and call C logistic factory. Right. Let's run it again. F5. I better remove this breakpoint. So now you can see, right, it is running all the method for C related, right? Now packaging goods with waterproof C packaging, generating international C cargo invoice, delivering goods by ship. Mode of transport is C. So this is about factory design pattern. So best part of abstract factory design pattern is this: if tomorrow I want to add an air delivery toolkit, right, all I have to do is create a new folder for air family, right? So I can create toolkit for air family too, right? No change is required in the existing factory logic, right? So my existing factory logics will remain same, right? I just need to add one more logistic factory for air, right? And I can simply plug and play and expand my business to support airplane or airway as a delivery mode, right? So that's the beauty of abstract factory pattern. It lets your ecosystem grow without touching existing code. Just plug in a new family of object and your system is ready. Okay, let's see some use cases of abstract factory pattern. So in cross-platform UI, right, you can use abstract factory pattern. Maybe you're using some buttons, right, based on platform, right, operating system, Windows, Mac, and Linux. You are inheriting some styles, right? So better utilize abstract factory pattern there. Theme switchers, right? There also you can utilize abstract factory pattern. Automotive manufacturing, right, where you're designing different cars, petrol car, diesel car, or electric car. There also you can utilize this. And then you have cloud providers SDKs, right? Maybe you're using some services from AWS currently, right? Maybe you're using some storage, maybe you're using some EC2 instance, right? Now in future, maybe you want to add support for Azure even, right? You're replacing S3 bucket with Azure Blob Storage. So there also you can utilize abstract factory pattern. You can define some generic interface there. And in game development also, abstract factory pattern has use case, right? All right, let's move to QA section. So these are the general questions asked on abstract factory design pattern. So the first question is, how is abstract factory different from factory method, right? So abstract factory creates entire families of related object. Factory method creates one product at a time. So think of abstract factory as give me a whole product set. Factory method as give me one specific product, right? Second question, is abstract factory overkill for small apps? Sometimes yes, right? If you only need one object type, factory method is simpler. Use abstract factory only when multiple product family exist. Product must stay consistent with their family. Third question is, can I combine abstract factory with dependency injections? Absolutely yes, right? Here I'm passing manually, right? Those types, right? If you have seen video, right? In implementation, I was passing road logistic, then I passed C logistic. There I'm passing this object manually, but you can use dependency injection to define it dynamically. In fact, this is preferred way in modern architecture. You can register factories in DI and switch product families based on tenant, based on environment, based on theme, based on configuration. Fourth question is, does abstract factory violates solid or help it? Of course, it supports solid principle, especially OCP, open close principle, right? You add new families without breaking old code, right? The second one is DIP, client depends on interface, not concrete product. So we have used interfaces, right? Generic interfaces to implement factory design pattern. So again, it is following DIP, OCP principle. And the last question is, why not just use inheritance instead, right? Well, inheritance gives you behavior. Abstract factory gives you consistent product groups. Both solve different problems, right? So that's abstract factory pattern, one of the cleanest and most flexible ways to manage product families in your application. If you're building cross-platform, multi-theme system, modular architecture, this pattern will save you tons of refactoring pains later. If you enjoyed this breakdown, hit like, subscribe button, and see you in the next design pattern video. Thanks for watching. Keep learning, keep improving, and as always, code smart, not hard. See you in the next video. Thank you.